Hello, it is June 6, 2020, and today we are going to look at a Fillomino puzzle by Elyot Grant at Grandmaster Puzzles at gmpuzzles.com. As always, if you want to try the puzzle, take a look at the link below, and you can solve it there. And we're going to take a stab at explaining how this puzzle works. This is a 4-star Fillomino. So if you've never done a Fillomino before, this is not the puzzle that I would start with, but it does have a lot of cool interactions in it that I want to talk about. So let's talk about Fillomino puzzles. Fillomino has a very simple rule set. Our goal is to divide this grid into a bunch of regions such that every number is the size of that region. So this 1, for example, is a region of size 1. This 3 is a region of size 3, whether it goes these 3 right here, or these 3 right here, or these down there. Don't know yet, but it's got to be a size 3 region. The only other rule is that regions that have the same size can't be adjacent to each other. So this 1, I know, cannot be next to another 1 square region. This 3 cannot be next to a 3 square region. And that's it, believe it or not. There's one kind of unstated rule, because it's just something we don't want to assume, and that is that there can be hidden regions. So, for example, there may be a 1 region right here that doesn't have any clues in it, and that's perfectly okay. So we have to keep on the lookout for these unclued regions, because they can exist. So let's take a look and see if we can figure out how to do this. So we'll start with the 1s. 1s I'll just draw a square around because they're kind of given. These 2s here and here are also easy things to throw in the grid. This 3 is going to have to extend outwards, and this 6 is going to have to extend outwards as well. And that's pretty much it for easy Fillomino deductions for this puzzle. So at this point, one thing that we can do with harder Fillomino puzzles is we can figure out, well, how many regions are there? So for example, there's these two 24s, and I want to know, are they two different 24 regions, or are they the same 24 number region? So to do that, what we do is we say, well, okay, this is 15 by 7. 15 times 7 is 105. And then I can look and I can figure out, well, what is the minimum number of regions that I have accounted for? So we've got a 24, we've got a 20, and a 17. We've got 4 1s. We've got 4 3s. We've got 2 6s. We've got the 2 2s. And then we have either 1 or 2 5s. So let's assume right now that it's 1 5. If I add up all of those numbers, I get 98, which means that if there's 1 5, there's only 7 squares unaccounted for. And if there's 2 5s, then there's actually only 2 squares unaccounted for. And so that means that there definitely cannot be 2 24s or 2 20s or 2 17s. These have to connect to each other somehow. So once we realize that, we can determine that that has to be true, the next thing we have to do is figure out, okay, well, how do they connect? So I don't know how they're going through this grid, but I do know that all 3 of these need to make their way past these 5s somehow. And if you look, it turns out that there's only 3 squares that they can kind of make that trip through. There's a square right here, so one of them has to go through here. One of them has to go through here, and then one of them has to pass through the middle of these 2 5s. So that at least allows us to realize that there's going to be a path through the middle of these 2 5s. And that determines that, well, okay, if they're being cut off, that means that these 2 5s have to be separate 5s. They can't be the same. So that means we're up to a count of 103, and so there really are just 2 extra squares in this grid. And we will use that later. Okay, so now what? So I know that this has to be a 17, 20, or 24. This has to be another one of those, and this one has to be the third one. So let's take a look right here. This one is going to have to snake its way up through here, which means these two squares are going to end up being the exact same number. And if you notice, this 3 is going to get cut off, so we have to make this 3 go this way, which means that this number is going to snake up this way, and we know that these two are different, so this one's going to go this way. Okay, so that's some progress. Still don't know which numbers these are, though. Let's see if we can do it on the other side. So this number right here is going to end up being the same as this number. And so now we have the exact same logic on this 5. This 5 can only extend 1 over this way before it gets kind of trapped by these 3. So this 5 is going to come up this way, which means that whatever number this was is going to end up sneaking through this area right here. And that allows a little bit of deduction. So we know this 3 has to go this way. As I said, actually the 3 means that this can go down and over like that. Now this 5 is going to have to come this way. Whatever number this is going to have to go 1 further, which means that the third number is going to have to hug the grid. And so these are going to come up like so. This 5 comes up like that, and the 5 finishes off right there. So this one's going to come upwards, which means this is either going to be the 20 or the 24. The 6 is going to come up that, drew an extra line. So this goes this way, and now notice this one is going to hit the 17. So all of these numbers have to be the 17. And this one's going to snake in this way. The 3 we can finish off, so that goes that way. So this is going to come this way, and good. Okay. So what else do we know? Well, this square right here, we know it can't be a 1, so that means this one has to extend out this way, and it's going to be part of this larger thing here. By the way, that's going to happen over here as well, that this is going to have to snake through that way. So the question is this big one part of the 20, or is it part of the 24? So let's assume it's part of the 20 for a second. So that would mean that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we need to make it to this 20. So that would be 16, 17, 18, 19, 20. So turns out that in order to get from here to here going this path, that would actually be 21 squares. And so this can't be the 20. This has to be the 24. So we'll fill in a 24 here. And those all have to be the 24s, which means the 20 has to come this way. This square can't be a 1, so it's got to be a 24. And now we know all 3 of these numbers. The 6 is going to come up this way, which is good. So now what? Well, we can ask ourselves, where does this 24 go? So it only has 2 paths. It could go through here, or it could go around the 20. But the thing is, if it goes around the 20, it's going to cut off both the 17 and the 20, and they would never be able to connect, which means that this and this need to be 24s, which means 17 has to go up that way. Okay. So let's take a look at this 6. So let's assume that the 6 doesn't go this way. Oops. Don't think we can assume that. There we go. The 6 doesn't go this way. It's going to have to do this. So how many squares do we have for the 24 at this point? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That would be 17, 18, 19. Oh, well, actually, it just cuts off the 24, doesn't it? Didn't even notice that. That's an even easier deduction. We don't want to cut off the 24. This 24 has to go that way. So yeah, so this goes 4, 5, 6 down that way. This 3 goes here. We know that this has to be, can't be a 1, so it's got to go this way. Well, so now we can ask ourselves, what's down here? So as I was counting, we got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Well, that 24 has to go that way. So we've got 22 of the 24, assuming we just make a straight path, which means that these are not going to be reachable by that 24. So that means, and these are not reachable by the 6. And remember, we only had 2 squares that we didn't have a region for, which means that these, oops, not 32. Let's try 2. There we go. This has to be a 2 region, and now every other square is going to be one of our regions that has a given number in it. So that should be helpful. Okay, let's take a look at the 17. So the 17 goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if it were a direct path, which it can't be, because that would cut off the 5, we know that it would be 14. Every time you go past this point, we're adding 2 squares. So if this square had to go around here, then that would add 15, 16. Which would leave 1 extra one. If it went 2 extra, it would end up cutting off the 20, which we don't want to do. So let's assume for a second that this 17 goes down here. Well, then this 5 is going to swing around here. The 17, this 5 is going to have to go to one of these 2 spots, but then the 17 would end up cutting off the 20. So that's no good. So that means that, how far did I? Yeah, that means that instead of this being a 17, this is going to end up being a 5, which means that the 20 is going to have to come down this way. 17 is going to come this way. This 5 is going to have to break out this way, which means this 17 is going to come down here. The 20 is going to go there. The 5 is kind of fixed at this point. 24 comes down this way, and then this 6 finishes off here. I believe we've got 16 out of the 17 squares, 5, 7, 10, 14, 15, 16, so the 17 has to go 1 more. This 24 is going to have to go 1 more. These are all going to have to be 20 because we know that it's got to be part of a region that has a given. So these are all 20. So now we can figure out how much left of the 20 is there. Well, there's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then I think we have 1 extra left in the 24. So we'll just make sure that's 1, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So you have 1 extra in the 24. And then the 6... and then the 3 comes like that. We can check our work. Hey, look, it's a completed Fillomino. So yeah, this was a fun one. I liked the connections that you had to make with these 24, 17, and 20. This played, I thought it was going to play a little bit like a number link puzzle, but in the end it didn't really. Just some bare similarities to a number link, but yeah, very logical solve once you figure out there's only 3 choke points. So hopefully this was helpful for you if you got stuck on this puzzle, and we will see you next time.